Okay, so yeah, welcome to the St. Louis Full Stack Web Development Group's 28th meetup. We're going to talk about infrastructure as code and Amazon Web Services as a topic. So hopefully you guys are excited for that. So I guess just before we get into this, just kind of a disclaimer, I am not a system admin guy whatsoever. I just recently sat for the AWS SysOps certification late December. And so in studying for that, I came across a bunch of VPC concepts and whatnot. So I kind of wanted to just share some of the stuff that I picked up along the way. But yeah, I've never set up like an on-premises data center or anything like that. So if anybody has anything remotely touching on that kind of experience, definitely feel free to chime in when I misstep, because I will. And this is a guided discussion as always. So if anything doesn't make sense, or if you got your own thoughts or whatever, feel free just to chime in, and we'll get to the end eventually. So I'm assuming that everybody in here is aware of cloud computing, maybe has some experience. So I'm not going to belabor it. I just kind of want to do a high level set before we start talking about VPC concepts and CloudFormation. So some of the old world pre-cloud computing problems, you see the big three. For IT infrastructure, you got massive, sizable upfront obligations and costs to have a data center of any size or complexity. Lengthy installation times, even once you maybe procure your equipment, actually getting the equipment ready for production or ready to go, it can take a while. And then once you have your equipment up and going, just maintaining that can be an issue. And so cloud computing kind of solves those problems to different degrees. So the big one is the upfront capital expenditures, not necessarily having to come out of pocket immediately, but converting CapEx to operational expenses. That's a huge plus, for a lot of small fries such as myself, probably all of you, if you don't have the upfront funds, having a data center is just outside the reach of possibility. So that's great that we now have this option for on-demand computing expenses that we don't have to commit to up front. So on-demand infrastructure, so those long installation times. I guess cloud computing has been around for decades, but in this current version that we've seen for about the past decade or so, that on-demand renting computing resources, that's huge. And so once you rent your equipment, it essentially is ready immediately to a greater or lesser extent. So that really helps with the long install times. And then as far as maintenance, there's minimal maintenance, maybe even zero, depending on what type of service you sign up for. So you're not messing with any hardware. It's all software because it's rented. And like I said, that's, maybe OS patching or, SQL patching and stuff like that, making sure your firewalls are configured properly. And maybe even zero maintenance, depending, like I said, on what you have purchased. So for cloud computing, Amazon Web Services is the big kahuna in that space. You see the logos on the bottom right. Those are the four biggest providers of public cloud capacity. So Microsoft, Azure, Google, and IBM. But Amazon really kind of sets the tone for the rest of the industry. At least 2 years ago, there were estimates that Amazon was 12 times largest than the next 5 competitors combined. That number obviously has shrunk, especially with Azure making inroads, but Amazon still seems to be kind of the thoroughbred. It was established anywhere between 2004 2006, depending on who you ask. Simple storage service, which is their object storage that Amazon offers, that was offered in 2006. And a lot of people cite that as the first AWS component that was made available. But they technically had the simple queue service available in 2004, I think. But I think that was before AWS was a real thing. So regardless, they've been around for about 11, 13 years. And then the others have come, a little bit after that. And you've got 3 tranches of cloud computing services. You've got infrastructure as a service, platform as a service, and software as a service. So infrastructure as a service is like your bare metal, quote unquote. So you're not really dealing with any metal, but just if you get a bare bones virtual machine, it's not really configured with anything, there's no applications, but you're able to rent that capacity from a cloud provider and put your own applications on it. That's your IaaS. Platform as a service is the next level up So it's not just bare metal infrastructure. It's actually a managed application for you. Amazon, in particular, offers several PaaS type offerings. Here, you're not really you're not administering you don't have to worry about backing up anything or patching. Amazon will handle that for you, but it'll cost you a little bit more. And then for your SaaS offerings, it's now your end applications that you're kind of renting out. So when people think SaaS, I think a lot of people probably think of Salesforce and their CRM suite. Amazon's starting to get off into that space as well with things such as Workmail and whatnot. So, not just the bare metal, not just the application or the structure of the application, but the actual application itself. And again, I would imagine pricing would be a little bit more for something like that. And this is just a snapshot of the new Amazon list of services. I just want to make the point that there's just a lot of stuff that Amazon offers. And if you're really looking for a point of differentiation between Amazon and those other cloud providers, it's going to be something like this, where just the breadth of offerings is more mature and robust on the Amazon side than the others, even though they are catching up. But for the components that we're going to talk about for this presentation, your virtual machines or your block storage, stuff like that, Google, Microsoft, IBM, obviously they're all fine in that regard. But yeah, there's just a lot of stuff that's happening, a lot of cool stuff that Amazon's starting to push out, like machine learning, which I haven't really done anything with this, but had an intern where I worked. He was working with Amazon Lex, which is pretty cool. This is stuff that he was doing, some analytics. There's a lot of stuff that Amazon's offering. That's actually a plus and a minus because they're throwing a lot of stuff at the wall and seeing what sticks. And so, you may find yourself falling in love with a certain offering and then 6 months later is decommissioned or deprecated or whatever. So, but yeah, there's just a lot happening in this space. And again, not to shortchange the other guys. They've got, offerings similar to this as well, but Amazon is definitely the premier offer. So the key components that we'll talk about in this presentation, EC2s, which stands for Elastic Compute Capacity, so ECC, EC2. That's the virtual machine. So, Amazon provides all operating systems, Linux, Microsoft, Windows, I think Solaris, at different sizes and different specs. So that's kind of like one of the cornerstones of any data center, obviously. EBS, which stands for Elastic Block Storage. So this is where you want to attach an EBS volume to an EC2 virtual server, and this is where you would store your data, especially if you've got a traditional database, you'd want to store that on an EBS volume or volumes. S3 is that simple storage service, which again, some people cite as the first AWS offering. This is for your object stores, so you wouldn't necessarily want to house a database on S3, but you maybe house the database backup files you would put in S3 or images or binaries, stuff like that. So that's another offering. VPC, that's virtual private cloud, one of the cornerstones of this presentation. That's where you carve out your own area in the Amazon cloud neighborhood, and you have your own dedicated networking, IP addresses, and whatnot. So CloudFormation is coded infrastructure for all of your Amazon components. So you can go through and you can create your Amazon components manually through the console, or you can actually write code and invoke that code and have your data center, your infrastructure spin up automatically.
I like the equivalent of a shell script for the.
Yeah, it's in like YAML or JSON, but yeah, pretty much. Absolutely.
And did you say you were going to go into detail on all these today, or you're just saying what some of them?
Yeah, not all of them. So we'll talk about EC2s and EBSs and VPCs and CloudFormations, but the bottom two, I don't really have. I mean, if we can talk about whatever, so if you've got thoughts or questions or, caveats, definitely. And honestly, I'm not a sysadmin. I haven't messed with all of these services either. So I've actually yet to really work with RDS. I haven't, which is the last service. That's Amazon's managed relational database service. I've done a little bit of stuff with S3, but primarily when I've worked with Amazon, it's been the basic, vanilla EC2 EBSs. And then just for this presentation, I've really started working with CloudFormation. So if we have CloudFormation experts here or whatever, please feel free to chime in. And, but yeah, so then the last piece is the managed relational database. So this is that PaaS offering. that Amazon offers, and I'm sure Google and Microsoft and IBM offers something similar. But you can just get an EC2 server and an EBS volume, and you can put, say, SQL Server or MySQL or Postgres on there, and you can manage that yourself, and that's fine. But Amazon also offers managed databases, so they will back up Postgres for you, restore it, make sure it's patched. I don't know about migrating to different versions, but they essentially serve as your DBAs if you use their RDS service. And you just have to worry about your database schema and your database, the data in your database, but you don't have to worry about actually acting as an admin. And so that costs a little bit more than if you were to just take that on yourself, but that's another thing that Amazon offers. So yeah, sorry, unless you guys want to delve into that kind of stuff.
I was just curious. Well, because I do have one question. Let me know if you answer it later. But this is something that always confused me. Like, why would you choose the EBS database versus the RDS? Is the EBS more just like a key value store kind of thing?
No, EBS is just block storage, so it's available storage for you.
Dynamically, it's like a hard drive.
Yeah, it's hard drive. Yeah,
it's a dynamic hard drive, essentially what it is, and you mount it to your EC2.
Yeah. You'll see that when we spin up an EC2, you'll have a spot for your EBS volume that you can mount. You can mount multiple volumes.
And maybe even your RDS database would live on EBS.
It absolutely does. But what you could do is the true comparison is I have an EBS volume and I want to put MySQL on it. So I do that. MySQL is free for the time being. And I manage that. And I've got my database, and if I want to back up MySQL, I back it up. If I want to restore it, if I want to patch it, whatever, that's me. And all I'm really paying for is the EC2, the compute, and I'm paying for the EBS storage. And that's it. If I want to use the managed relational, Amazon offers a MySQL of that. And it's the exact same setup, except Amazon's going to back all that stuff up. It's going to worry about restoring, right, and patching. And exactly. But it'll cost you a bit more for that luxury. But that's totally where they're trying to push you. So if you are studying for any of these certifications, Amazon will, like if you're reading the materials, it's all going to be about like Amazon's offerings. They talk about Aurora and Route 53 and all that stuff, which is cool, but it's like, man. Exactly, right. So
to expand on the EBS, again, I'm not an expert. I've just been doing some research lately. So like if you wanted to run a media server, it's going to have a large amount of space and you can't ever predict how much space you're going to need. You would stand up the actual software on the EC2, then you would mount an EBS, and you would just send it files, and it dynamically grows as you need it to. He pointed out databases.
I don't know if vanilla EBS does. I'm not 100% because I've never really put a lot of data up in there, so I don't know if it just automatically. EFS will automatically, exactly.
EFS?
Yeah.
EBS does not dynamic.
Does not.
You have
Okay.
a fixed volume, that's it. Say a lot for EBS versus S3.
If you instantiate 20 gigs, whether you use 20 gigs.
Yeah, that was going to be a point made later.
S3
Yeah.
dynamically.
Yes, exactly.
You never did fill up S3.
EFS, yeah, that's elastic file system. Yeah, that's relatively new.
Sorry, I did get those confused.
That's the disadvantage of that previous slide where we're like 50,000.
Yes,
Exactly.
Well, and you've got EBS versus EFS. I've never confused those.
Yeah, that's
Right,
like
right.
network file system for cloud.
All right, so interacting with AWS, there are three main ways of doing it through the console, which we'll do, hopefully, depending on our internet connectivity. So that's, just GUI. CLI, if you want to invoke this stuff via command lines, you can do that, which is nice. If you want to programmatically, work with your components like that. And then software development kits, multi-language support, pretty much for all the most popular languages. So yeah, within your PHP app, if you got a user uploads an image, you want to store that in S3, you can do that via the AWS SDK for PHP or Java or Node or whatever. So like I said, for this presentation, we'll primarily interact via the console, but these are two other options as well. Yeah, we'll go through the terminal. So has everybody who here hasn't used the AWS console? Raise your hand if you have not. Okay, all right. So I won't belabor this too much, but I just want to show kind of just spinning up an EC2 instance. So we go back here. This is that crappy slide that we had, but it was like 2 of these. But yeah, these are all the services that Amazon offers. And so we'll get into regions in a second. I'm right now in the Ohio region. You see you've got a bunch of different regions worldwide. I'm in the Ohio region, and I just want to spin up an EC2 instance, a virtual machine. So you can go to the recently visited services up here, or it's down here as well. And you see just a boatload of options for us. Click on EC2, and you see I have 0 running instances, 0 dedicated hosts. Just not much happening. Got some security groups that I had stuff out there that I've deleted, but again, I'm just showing this for people who aren't familiar with the interface. And you can just go into running instances, or I can just click launch instance from here. I just, for whatever reason, always go into here. This is where I actually interact with my EC2 instances, which I have none in Ohio as of right now. So if I go to launch, all right, and this is where we see all of the options for us to spin up a virtual machine. So usually I stay with these upper ones that are provided by Amazon. So you see there's a Linux one, there's a couple others. Ubuntu's the server I usually operate with. Different flavors of Linux. Down here you see Amazon already pushing their RDS stuff immediately. They want to get that money. Windows at work. If I'm doing stuff at work, I usually am using the Windows EC2. And then there's deep learning AMIs. And so I guess AMI is probably, I should explain what this is. That's an Amazon machine image. And so any EC2 that gets spun up needs to be spun up from an AMI, which is, you could think of that as a blueprint for your virtual machine. And each AMI is its own unique blueprint, and it has its own unique identifier within all of AWS, and that's what these things are here. And that'll come into play when we talk about CloudFormation. But yeah, it's just as simple as just picking which variant of a machine you want and hitting select. Before we do that, I usually start off here, but you see also we have my AMIs, which I don't have any, but if you spin up a machine, put your own software on it, and then you want to make a snapshot of that, you can snapshot that, and that'll be your own custom AMI. And then later, if you want to spin up other machines from that, you'll already have your custom software on it. What's up?
On Windows, what's the license?
Is so the cost. So we can look at pricing later. So you'll see the price for a Linux machine is like maybe 2 cents an hour. Corresponding Windows machine will be like 30 cents an hour, something like that. So yeah.
So it's covered in the provision.
Yeah. And I think they have other options if you want to bring your own license. They've got options for that as well, but I don't have that. So then another cool thing is AWS has a marketplace. So you have third-party sellers that will give you custom software or, paid for software on their AMIs. And again, that'll be reflected in their pricing. But, you can get a lot of stuff out here. F5, Splunk, I'm not familiar with Barracuda. And it could be bona fide companies, but also just, third-party individuals selling stuff as well. Hopefully all on the up and up. But, yeah, if you put together a nice setup and you got, Java and Neo4j and all sorts of stuff already nicely configured, and you want to try to make a few bucks off of that, you can, put it out there in the community and see if people actually are willing to pay for it. So, like I said, I usually don't spin up from the community, just don't. But I guess that's really going to be here as the community AMIs. And again, all different identifiers, and you kind of get a little synopsis of what you're going to get with this AMI. I don't know if there's like a rating system, like with Docker with the images or whatever. I'm not sure if we have something like that here or not, but like I said, I'm just doing this more for show. So, but anyways, back to the quick start. I usually, like I said, I go Ubuntu for the most part. And so here, you got your instance types. This is where you're kind of configuring your, I'll say hardware, but the specs of your instance. So you got virtual CPUs, memory, all instance storage now is EBS only. There was a day where that wasn't the case, but every EC2 is going to be backed by an EBS volume default, which is probably for the best. And IP6 support. I usually stay up here because the deeper you go down here, the pricier it gets on you. And we can look at pricing later because there's been a couple questions already about it. But yeah, so obviously the nice of the specs, yeah, right. And so then I guess, and I'm not an expert on Amazon. The type though, you have these different families, I guess. And so general purpose is for general purpose, and then you have compute optimized and GPUs. And yes, if you want compute optimized, you probably should stay in this family. But as far as like a 16, CPU, 30 gig compute optimized, how does that compare to a GPU 64, 48? I don't really know how to make that translation, whatever. But yeah, Amazon has like maybe 5 or 6 different families. You got memory optimized, storage optimized, so I guess for your throughput maybe. And again, I don't usually wade in these waters, but we are going to mess with the lowly T2 Micro, which another cool thing, if you sign up for AWS your first year, you get a free tier of services. So you get one EC2 Micro for essentially an entire year free, just if you just leave it running. And I think back with like a small EBS volume, you can kind of play with that for a year and it doesn't cost you anything. And so that's an eligible one. I've been past that for a while. Anyways, so you would pick that. You want to configure the instance. So you can set the number of instances you want to run up here. Here's where you select the VPC that you want it to go into. So I only have one VPC associated with this region. So it'll just be that. And again, that's my own neighborhood in AWS. A subnet I'm going to associate it with. And I'll explain that later. IAM roles we won't really talk about today. And I usually don't mess with too much here. Where's the tenancy? Oh, there we go. Thank you. So yeah, tenancy, you want to make sure you're on shared and not on dedicated or dedicated host. These are virtual machines sharing, space with a lot of other virtual machines. But if you really want your own dedicated space, you can get that. But obviously, that'll really cost you. And I don't even know what that costs. But by default, Amazon always starts you off with shared, which is the way it should be.
Right, what was at the top it said number of instances?
Yeah.
Is that just if you want to have create 5 different servers at the same
Same time, yeah.
Okay.
All from the same AMI. Let's see here. And some of this other stuff I'll explain in a second when we get into the VPC stuff. And so next we'll add the storage. So this is that EBS volume, and this is what they're talking about, where you want to provision the amount of gigabytes that you want. So it starts off at 8. We made the mistake at work because we're Microsoft and we were trying to put other software on there. We were starting ours off for like 200 gig because, we were trying to somewhat replicate our on-premise network. And we were dutifully stopping our instances after work and then starting them up only during the working hours. But with the storage, you get charged right. And we're spinning up bunches of these things, so we kind of got our hands smacked a little bit not too long ago about that. So we're back to like doing 20 gigs. But yeah, you could, however much you want. And again, it doesn't matter if you don't have anything stored. You're going to pay for the 20 gigs 24/7.
Do they, at any point in this process, do they show you what the pricing will be based on timing?
No.
You can go to AWS simple monthly calculator.
Yep.
public URL,
Right.
and it'll let you put in the EC2 instance size, storage, everything. It's a publicly available URL.
Yep.
AWS simple monthly calculator.
Yeah.
And then you can calculate out what you're going to cost for storage for EC2.
But one big downside that you can still get on Amazon now is you can't set a price ceiling. So you can just it'll just charge you a credit card. With some of the other services, I think Google maybe you can set I don't want to spend $100 a month, so if you get turn stuff off, it'll kill your instances. You know what I mean?
You could rig something like that up for yourself, but what you can do is set up billing alerts. Yeah, you get an email.
One of the Amazon downsides, you can get out of
Oh, it's a couple others. We got a slide for that.
How much
Yeah,
bigger once you stop spending money?
right.
You know?
Yeah, but yeah, Jordan, to your point, you're not gonna get a pop up right here saying, "Hey, watch yourself." So yeah, we'll actually keep it at 8. Here we have the termination, so that's an option that's checked by default. EBSs and EC2s, they're not conjoined twins. They can exist, independent of each other. So there may be times where you want to tear down your EC2, but you want to maintain that data. So if that's the case, you want to uncheck this, because when you delete your EC2, if that's checked, it's going to delete the corresponding EBS volume or volumes set up. But if you want to watch out for your money and you're just playing around, keep this checked. Or if you want to, if you want to tear down your EC2, but first you want to take a backup of the EBS volume and then make sure you tear it down, keep that checked. And it's probably just good to keep it checked just so you don't have any price surprises. You can also attach multiple volumes to a single EC2 if you want, different sizes and whatnot. So,
Is it installed the OS on this EBS?
I don't think on the EBS. I think those are just drives. Yeah, I think it's just on. Oh, it's on the root volume?
So your first volume, the root volume, is where your raw should be installed.
Oh, I got you. Okay.
Your second volume would just be, if it's Windows, I guess it's drive D.
Yeah.
If it's Linux, it's just another block device.
Right. We'll do that. Delete this in termination. I guess you can encrypt if you want. We'll do that. Let's see. So adding tags. Tags are kind of cool. We'll see those in the CloudFormation template. Just arbitrary key value pairs that you set up. I usually have a key with name, and then just test. I'm not really sure what these are for. Security groups we'll get into here in a little bit. I'm just going to keep this as a new security group, and this will be on launch. You get a warning from Amazon just saying that the security group is open to the world, just because we haven't really said anything on it. And then you launch. And then you have the concept of key pairs, which I guess I'm not really going to tunnel in, but this is another security mechanism, which I guess you don't technically have to have a key pair. So we'll see without one.
Is that just like an SSH public key?
Yep. Yeah, totally. And so now we're launching, and it usually takes just a few minutes to get this up and going. And like I said, there's nothing really cool on this. I mean, I'm going to jump back to the PowerPoint in a second, but we have a virtual server that's up and running, and that took longer than it really needs to. It should only take like a minute to really do that, but that's really, really cool, just to have that capacity on demand. And yes, you got to pay for it, but if you hate it that much, you don't have to pay for anything and just don't use it. So, but yeah, and it's really cool because you just launched into this VPC, and it's got DNS already set up. You got a public IP address, you got an internal address. You have some security that we kind of just blew through, but it's already set up and ready to go. So I think that's really, really cool. But yeah, I just wanted to kind of show the GUI, just doing something very basic, just launching an EC2 manually. That was that. So with respect to the VPC concept, so VPC stands for Virtual Private Cloud. This is like your networking stuff. Amazon has a lot of these diagrams floating out there on the internet, so I just grabbed one that just kind of showed a basic VPC setup that we'll replicate in CloudFormation. So the concepts of VPC that are relevant, region, so we already kind of talked about, we were in the Ohio region there. Amazon, as you saw, I think it has like 14, 15 different regions throughout the world. These geographic areas where Amazon houses its data centers. So that's the first high-level concept, and that represents this outer line.
So you have to, if you have a lot of servers to talk to each other, they have to be in the same geographic.
You would probably want that. So yeah, you can go cross-region, but data transfer costs and stuff like that, and then latency and whatnot. But Amazon always pushes for that because you want to have, a disaster recovery and all that good stuff. So, which makes sense. It's very prudent, but it also coincides with Amazon's profits too. So under regions, you have availability zones, and you can think of these as the physical data centers in which all of this stuff actually resides. And I think each region has anywhere from 2 to maybe 4 availability zones, depending on the maturity of the region. And so that's what these dotted gold lines kind of represent in this diagram. And again, so within each availability zone / data center, there's redundancy. I think there's 3 times redundancy. But you're not technically highly available if you have all of your components in a single data center. So within a region, you can, replicate your components for a fee. You're replicating your infrastructure, but that stuff can talk freely to each other as long as it's all within the same VPC. I think, fast and free, I think, for the most part. And if one data center goes down, you can quickly switch over to your other data center and you've got a highly available setup. But now, obviously, if the entire region goes down, that's where you have problems. I mean, that's happened on occasion to Amazon. So then you got your virtual private cloud. For the most part, all of your components will sit inside of your virtual private cloud, which is just essentially a series of IP addresses, and you got your network interfaces and stuff like that. But that's your block in the Amazon ecosystem. And I think you can have 5 virtual VPCs per region. You could probably do more if you call Amazon, but I've only messed with 2 ever. But the VPCs, think of those as like their own neighborhoods, and everything within the VPC is fine to talk to each other. It's just when you want to start having VPCs talk to each other or go across regions and stuff like that, that's where the cost will probably go up and the performance probably drops a bit. But you may need to have something like that set up. So then you have subnets, and so when you get a VPC, depending on the cedar block that you establish, you can have up to 65,000 IP addresses for your internal IP addresses for your VPC. Your subnets are just carving out those IP addresses, and so your IP addresses need to be unique. There can't be duplicates within subnets or across subnets. But yeah, that's how in the subnet cannot span availability zones. A subnet resides inside just one availability zone, one data center. You can have multiple subnets within a data center, but the subnet can't span data centers. You can have public and private subnets. So a public subnet is a subnet that's open to the internet via an internet gateway, which you see here, and a private subnet is walled off from the internet, and you want that for some of your more sensitive applications or your database and stuff like that. But again, a private subnet could still communicate with a public subnet within your VPC. That's all fine. It's just it'll be protected from the internet. And the internet gateway provides the direct connectivity to the internet. So, like I said, that's one of the things that you have to have in order to have a public subnet that's accessible to the internet. And router tables and the router are some of the other things that you need. And so we'll actually talk about that here on the next slide. You see the icon of the router, and here's the route table itself. So this slide's a little different as far as the diagram goes. So as far as security, we're not going to delve into security for this presentation, but out the gate, Amazon kind of gives you 3 different layers of security for your VPCs. So your router and your route table are one of them. And you can think of the router as like the rows for your traffic, and the route table is the directions. And I thought this would be a little bit bigger, and that's not great. Let's see here. So the way the router kind of works is that you associate a router or a route table with a subnet. And so it's just essentially saying, hey, any traffic that is destined for this IP address, I want it to go through this component, which will be some kind of component within your VPC. And so we're saying here, for this VPC, which you don't really see it, but the IP address range is this 10 block. So you've got, however many IP addresses all sharing this 10.0 address. And this is an internal address. And so this route table is saying, okay, anything that's destined for this, allow it to, just go local and stay local. Anything that's open, that's publicly exposed, we want it to go to this IGW ID. And that corresponds to this Internet Gateway ID, which you can't really see, but if you associate this route table with this subnet, that's what makes it a public subnet, because of this route that exposes it to the Internet Gateway. And so you see this other route table, same deal with the internal addresses, stay local, but you see for the open public addresses, instead of going to this Internet Gateway, it's going to this virtual private gateway because of this different ID. And the virtual private gateway is what allows you to connect your AWS infrastructure to your on-premise infrastructure. It's one of the ways you can do it. So if you associate this route table with this subnet, that's what makes this a private subnet. And if you wanted to make this a public subnet, one of the things you would have to do is to make sure this route essentially associated with this route table, and it would just magically start, directing traffic to this internet gateway. Does that make sense?
Is the route table like a separate component that you configure from the router, or is it added, associated with the router, or is it within the router itself?
Yeah, I couldn't really answer that. I've never actually configured the router itself. It's just the route table and then the specific routes. So I think of the router as like the hardware that I don't have to think about.
If anyone knows this, I wonder if, are they just using like the term router and route table because it's a familiar metaphor from how you physically set up a network, or are you really because it's almost like this is just a server on any other host, and it's like, oh yeah, I have my router and I gotta set up the route table. I wonder if you're really like a metaphor, it's just a metaphor for the interface or something.
Yeah.
Well, it's network terminology, it's how you connect with the network.
Yeah.
So that's because they let you segregate the network, they now have to provide a router so you can allow two networks to talk to them. And the internet and your local network are two different networks, so you have to have something in between. It's essentially probably a juiced up version of IP tables.
Yeah.
It's probably what it is.
Well, I guess that's the thing that always is mysterious to me about Amazon. It's like, on the one hand, they're like, oh, we have created this abstract, like S3, it's a bucket for storage. You don't have to deal with a file system and this, that, and the other. But then on the other hand, it's like this, and it's like, well, we're giving you all the same tools that you have. You have your own server. It's just our, it's like it's always like mysterious to me where you draw the line.
Sure.
Oh, well, this is an Amazon specific thing versus, no, this is an industry standard thing. We're just posting it for you. I don't know, but there's a point. But
Yeah.
Especially when you're routing it here, everything that you're basically running relies on your standard core infrastructure and gateways to be constructed similarly versus if you run a SaaS, then it's all done for you.
Right.
This one, if you run a reverse proxy, you have to forward the server to talk to it. They run it on hardware.
Is anybody familiar with DHCP? Does that factor into what you guys are talking about at all, or no?
DHCP is just dynamic IP address.
Okay,
No,
so
You get from them, you get there's a private internal, and then you can have external IP, and then you can have ones that aren't locked to the box. So every time you turn on and off
They
the
change.
hardware, it changes dynamically.
Right,
Maybe
yeah.
you have to pay more money to get them bound, but every time this box comes.
Elastic, you do when you don't. As long as you're using it, it's free. But if you don't, then yeah. Okay. I didn't know that factored at all. Like I said, I'm not a sysadmin or whatever, so.
DHCP is just a server that the computer calls out to get an IP.
Okay. All right. But yeah, so yes, I configure the route table and the routes themselves, and we'll see that in the CloudFormation template. But the key takeaway is that happens at the subnet level. You associate that at the subnet level. And the next layer of security, we talk about the network access control list, same deal. You associate this at the subnet level. This is just another layer of control for traffic in and out of the subnets. And you set this up with rules, and you have different types of traffic and different protocols and port ranges. You have your sources, and you can either allow or deny the traffic. And you need to explicitly allow and explicitly deny traffic. And this, you can't really tell this is for both inbound and outbound. So I just did a crappy screen shot here, but it should be inbound or outbound. And so the idea is that even if you allow traffic to come in, you have to explicitly allow traffic to go out to that same source. When you use a network ACL. and you need to order these with numerical rules. And the way this works is when traffic comes in, when it hits the network ACL, assuming it got through the router or is going out, your VPC will just kind of go down the list in numerical order and just until it finds a match. And once it finds a match, then it says, okay, either I'm going to allow or I'm going to deny this traffic. And I guess best practice is to have kind of a default rule that catches all the remaining stuff. And I guess by default it is deny. But yeah, that's the next layer of security, and that's something that we would configure ourselves. And I think I have that set up in CloudFormation. I'm not sure. We'll see. The third level is security groups, which you already kind of saw when we were setting up our EC2 instance. Unlike the route table and the NACL, this is actually at the EC2 level, so within a subnet. Every EC2 has to have one of these security groups, at least one. You can have up to 5. And here you are explicitly allowing traffic, but you don't have to deny traffic. And you're not even actually able to deny traffic. You can only allow traffic. And if you allow traffic to come in, it's implied that you're also allowing the traffic to go back out for a request response. And it's kind of similar to the network ACL. There's not rule numbers, but you've got the protocol, and you got your port range, and you've got your source IPs. And unlike NACLs, where they go down the list until they find a match, with security groups, all the rules are evaluated. And I'm assuming that if there's some kind of conflict, that it will err on the side of pessimism and, I guess, deny. I'm not really sure. I've never really set up a lot of different security groups. But, this is how you kind of open your ports up for, let's see what we got here, for like HTTP traffic, SSH traffic, HTTPS traffic. If you wanted the port for Postgres, I think it's 5432. I think MySQL might be 3306. You want to make sure you're opening up those ports in order to allow these EC2 instances that are associated with these security groups to be able to talk freely to other components. Let's see here. So those are your 3 layers of security. You got your route tables, you got your NACLs, and you've got your security groups. And that's, again, just kind of out the box that you get that with AWS VPC. So next I want to just kind of show some of the VPC components.
I have another question.
Oh, yeah, no.
My experience with Amazon is mostly with S3, which I use a lot for work, and then so they have the AIM groups. Is that just like a not apply to EC2, or does that relate to one of those?
The IAM groups?
You can,
The IAM.
Yeah, absolutely.
Sorry,
I university can attach
Yep.
Instead of him using that key, you can attach a role.
Role, there you go.
Okay, so that's really more for like the management of the infrastructure, not for like public traffic
It's
users.
like boundary and access control.
If you use IAM, then you don't have to worry about that
The
key.
key, yeah.
Right.
You have 1,000 servers, 1,000 keys.
Pick your S3 buckets on
Yeah.
instances or whatever.
Amazon recommends that you use an IAM role over the keys now. And that's
Yeah.
one certification there.
Yeah, so when I said earlier, this isn't like a deep dive into security. That's one of the reasons, because had you not brought it up, I'm not sure if I would have brought it up to like the very end. So, but yeah, that's the preferred way of doing this. So let's see. So when you sign up with Amazon, you've got exposure to all these different cool geographic regions. Not going to spin anything up, and I think by default you get a VPC in each region. Let's see what this thing. I've never actually been out to this one. No need. This thing is spotty. So yeah, I have no EC2s out here, but if I want to go out and just look to see some of these VPC components, should be stuff out here already. There we go. All right. So yeah, like I said, I've never been to Mumbai. I'm not sure how new this one is, but already I have a VPC set up with, all these route tables and subnets already configured. So get this really nasty VPC ID, which is just kind of how Amazon tags all their stuff, which is why you really want to use tags to kind of, differentiate your names. But just remember this E15 VPC ID. I've already got subnets out here, or I should, yeah. And both of these you can see are associated with that same VPC. You see the route table associated. Because this one goes to the internet gateway, so that's a public subnet. I'm going to assume this one's a private one, but that's a public one as well. All right. But yeah, that's the route table. So both of these subnets are internet accessible. If I wanted to make one private, I would essentially need to come up with a different route table that doesn't have this and associated with that subnet. Got network ACLs that we were just talking about. And again, this is what I was talking about, the inbound versus the outbound. You got your different rules, and it's opened up all rules. All traffic is allowed by default. Okay, I guess it's both ways, inbound and outbound.
One major difference between the network ACLs and security groups is you cannot specify an explicit denying the security groups.
Right.
Do it in the network ACLs.
Yep.
And like what you said, allow deny, you have to do both. Stateful or stateless.
Yeah, exactly.
And then the security groups.
Stateful. Yep. Yeah, so again, this is just out the gate. If we wanted to add more rules, we could. And this is where the ordering comes into play. So, let's see. So yeah, so if I wanted to add another rule, but I wanted it to happen before this one, it would literally just be, hey, call it a 10 and, give it whatever we're doing over here. So yeah, so if any HTTPS traffic were to come through, it would be denied because this rule would be evaluated first before this one. And I've yet to really test this out. This is just off of the certification, so I'm assuming that's how it works. Definitely correct me if that's wrong.
No, I think that's right. I don't think if you do even inbound or outbound, it's probably going to deny HTTP 443. Just thinking off the top of my head, since that's stateless on the network ACL, doing either inbound or outbound might deny 443. But definitely will on inbound, I'm sure.
Right.
You don't have to get it one by.
So that's the thing, when I talk about stateful or stateless, stateful means it remembers what the inbound traffic was when it sends it out.
Right. Security groups, you can do that.
You only have to specify inbound, allow port 80, it's going to allow outbound port 80 by default. But it's also on the
And here's the subnet association. So if we wanted to change that up, which we could, won't do that just yet. Let's see. Look at the route tables already. Oh yeah, we touched on that. So the route tables. And yeah, not like I said, I obviously don't really know much about DHCP. I know it's kind of important, but I've never really messed with option sets, internet gateways.
You don't usually use that on any servers anyway.
Oh, right, okay.
Because you don't want to move around because you don't know where the hell they went.
Maybe if you
That's
have
cool.
machines that are like scraping or something and you have outbound.
It's usually just client machines that you don't care where they are because you're not going to initiate a connection to them. But
for servers that you want people to be able to initiate a connection.
Right.
And you want those assigned addresses.
Okay.
So if you're gonna spin up like an EC2 to do something dynamically, like spin up to batch process something, and then you gotta do it with an EC2, you might do PHCP with that because you don't care what IP it is that.
Okay.
Because it's only gonna reach out to your database and then do whatever it needs and then drop it.
All right.
Versus a server, you're gonna want it to be stuff.
Yeah, there's not really much with the internet gateway. And then, yeah, you got elastic IPs, which are helpful when you want to make sure you've got consistent, publicly accessible IP addresses. NAT gateways, we haven't really talked about, and I don't really have much in the presentation, but for the private subnet, if you want to still be able to have some exposure to the internet, you would want to route it through a NAT gateway, a network address translator. So you would put that NAT gateway, you would associate that with, I think, the public subnet, and I believe you'd want to have a route table route your private subnet traffic through that NAT gateway, and then that NAT gateway would be exposed to the internet. It would protect inbound traffic as well. So, and yeah, I've messed with NAT instances. You used to set up your own EC2. It was a special EC2 with NAT software, I guess, on it. And Amazon, I think, is suggesting people get away from that and use a NAT gateway, which again is at the subnet level. So I'm not really sure exactly how that differs from the instance itself, but it's the same idea. And then we have VPN connections, which I've never really messed with, but this is where you want to actually connect your on-premise setup to your virtual private cloud, and you can do that in a number of ways. So these are some of the different ways you can do that. I'm not sure about pricing or performance, but so that's just some of the VPC components. I just kind of wanted to go through the console and just kind of show just some of the configuration options that we would utilize. So then CloudFormation, so that's cool to do that, but if you want to programmatically manage your infrastructure, you want to use CloudFormation, which is another Amazon Web Services offering. So programmable infrastructure, I mean, this is literally, you can treat your infrastructure as source code. You can put that into version control, which at Lumeris, where I work, we're using Bitbucket to store our CloudFormation templates. I want to say there are unit testing frameworks out there, budding, I think, but I'm not 100% on that. But I mean, it's just either JSON or YAML, so I mean, you could at the very least come up with some kind of custom, homegrown unit testing framework for your infrastructure, which is really cool. But, less error prone, less tedium, in doing that as opposed to doing a bunch of point clicks. So templates are a big thing. That's the actual source code. Again, JSON or YAML, and that describes your resources and properties. You've got the concept of stacks, which is a collection of AWS resources that are managed together as a single unit. Chain sets, which I haven't really worked with, but it's just a way to update your CloudFormation, your infrastructure, but it also provides you a way to preview the changes before you actually commit to the changes. And then again, JSON or YAML, just data format options. YAML is a bit more readable than JSON, and you can also include comments in a YAML document, which I guess you can't with JSON. So I prefer YAML when possible. And so within a template itself, there are 8 sections for a template. Only one of them is required. So you have this format version, which Amazon has different functionality for different template versions. Is the idea behind that, but as of right now, there's only one format version. So if you want to specify, if you want to include that section in your template, you have to just make sure it's written correctly, which we'll see in the formation template that I have. Description, describes the template. You got some metadata if you want to add some key value information to your template. Mappings, pretty important for those AMIs. Those AMIs for the EC2 instances, they're regionally scoped for whatever reason. So the exact same EC2 in Ohio is going to have a different AMI ID than the one in Mumbai I don't know why, but if you want your template to be able to be used throughout regions, you need to have some kind of lookup table to look up those AMI IDs. Otherwise, I'm not really. You have to have a region-specific template because you'd be hard coding your AMIs, and we'll see that in the CloudFormation examples. But that's another section for your template. Parameters, you can pass in parameters. Resources, number 6. That's the only part that's actually required. That's where you're describing your resources. And then you have conditionals, which if, then, stuff like that, and outputs. We'll see an example of outputs where you can create these cross-stack references. So downstream stacks can use values from upstream CloudFormation stacks. So we'll see an example of that. Oh, that is horrible. Oh my God, I'm sorry. Let's see. Well, oh shit. Yeah, there's nothing we can do about that.
Is it like a text file on your machine?
Yeah, I mean, it got that. But, exactly.
You select all of that.
Yeah, how do I? Does anybody use Atom? Yeah, man. Not dark. You got me shit, man. I know, right? Oh, what happened?
There was another set of themes. I think there was one for the end of the issue. We're happy.
Okay. Oh, I got you. Okay. Shit.
If you scroll down.
Development.
Syntax has maybe.
So, yeah, this one here.
Sorry.
Thank you. Sorry, I'm just trying to find my stuff.
Let's see here. So, what's this? Oh, yeah. All right. So this is that format thing where this is the only eligible format that Amazon has, but I think the idea is to provide other template formats that have different options and functionality, but right now this is it. So if you want to include this section, it has to be this syntax. You got a description here. Got metadata. We're just showing just the key value stuff. And so here we've got resources. So this is our resources section. And we've got this identifier, which is just a logical, arbitrary identifier, but it needs to be unique within this template and within any other templates that would utilize, that would reference this template. So we got that. We've got this type, which this is pretty important. This obviously indicates what type of AWS component you want, and this is driven by Amazon. And this type value drives the available properties and the required properties and stuff like that. So here you see we're spinning up just a VPC. We got a Cedar block, which is probably required. And then we're saying, okay, we want to enable DNS support, host names, instance tenancy. We want to make sure that's default, not dedicated. Default's a shared, cheaper one. And then here we can just add tags, just arbitrary key value names. I think that was kind of all that was.
Next to the settings that are in the GUI.
Yeah. Except the template that I grabbed this from had dedicated as the default, which was kind of scary to see. So I caught that.
Maybe I missed. Did it give you that template somewhere?
Went out and, well, I mean, I could just written this myself, but I went out and Googled and just took it and tweaked it for the presentation. So yeah, if you just Google CloudFormation templates and whatever you want, there'll be a lot of examples out there.
Depending on the software, a lot of software companies will have a GitHub with all those templates on it.
Oh, sure.
You can run their stuff on it.
Right. And they also have the CloudFormation designer, so it's yeah, you can do that, and you just drag and drop, and it'll also generate your CloudFormation template for you if you want. I've yet to use it, but that seems like it's pretty helpful too. Let's see here.
I'm not that familiar with the YAML. Is it better things to put in quotes,
Oh.
strings, or is
Yeah, I'm not that familiar either. I know indentation's a big deal, so I think it's 2 spaces.
I guess I noticed the types, one was a string,
Right.
That's weird.
Yeah, you're right. Yeah, I guess it's not a
Because
stickler.
I see this if Amazon says that that should be a string, so they have to quote it. That's what's up.
I don't know.
Oh yeah, that was cool.
Then 25 and 32 don't match, or and 14.
Right. Yeah.
Maybe it's forgiving.
Yeah.
Good
It's
eye.
like 17 copy and pastes later.
That's yeah. So okay, we got that. Oh yeah, okay. A couple of CloudFormation template enhancers. You have reference, which I guess we already kind of saw here. We're referencing the VPC ID from up here when we're attaching our gateway, and same deal with the internet gateway. So that's one of the enhancers. Usually CloudFormation template will just kind of process sequentially, but you have different ways you can kind of control the flow. You got if statements you can use inside your template. You got substitution for variables into strings. You got the find and map, which for that AMI's map I was talking about, you want to use that function, and we'll see that here. And then export value, import values. Again, if you want to create cross-stack references, this is the syntax used to do that. And like I said, the templates will show some examples of this. And there's other stuff you have like wait for and depends on. There's some other, other functionality that you can have to where, just want to make sure your infrastructure spins up in the right sequence. You don't want to try to spin up an EC2 before like the VPC itself is set up. So, yeah.
It's weird that they made this like declarative configuration format, and then they're like, oh, let's add all this
Control, yeah, right.
programmatic stuff to it. Like, maybe should have done this in a Python script in the first place or something.
And so, yeah, the CloudFormation process is pretty simple. You create or use an existing template. We just saw that. Save it somewhere locally in S3. Go to the CloudFormation GUI or via SDK or CLI and invoke your CloudFormation template to create your stack. And then magically you'll get cool infrastructure. And so we'll do that here in a second. I guess we'll do that here now. Let's see. So we're going to get out of Mumbai. Go somewhere a little closer. Go to Northern California. Where I've been doing a lot of this work. So while that's going, just kind of want to walk through this template a little bit. So again, identifier is arbitrary, just needs to be unique within the template. And there's probably some reserved words you can't use, but this is the identifier for this piece. This is the identifier for this piece, and so forth. So that, first we set up a VPC, then we set up our internet gateway, and then we actually want to attach that internet gateway to the VPC, and that's what we're doing with these reference keywords here. Here we're going to create some route tables. We've got a public route table and a private route table. Again, just of the type route table. And again, we got some references happening here. And at this point, there's nothing that makes these public or private. Is once we get down here to the actual routes, that's what's going to really distinguish. So I got route public, and this is where we got the cedar block going to that internet gateway that we set up. And I don't think I set up private routes. But what I did do was I created 2 subnets, and I associated the route tables. Where's that at? Oh no, it's not that. Okay, so subnets are still, there's nothing that distinguishes them just yet. I'm just kind of setting up the right seeder block, making sure these IP addresses don't overlap or contradict the IP addresses from the VPC that we set up in the beginning. Setting up an availability zone. So I could have hard coded an AZ, but I'm just saying, hey, use this function select functionality that you get and use this function get AZs and just give me the first AZ that pulls up, and whatever data center that is, that's where this subnet's going to be. And doing the same thing with this other subnet, but I want to put it in the second availability zone. Yeah, I could have put this also in the same, subnet, or same availability zone, but that would have defeated the purpose, having a private and a public subnet. Let's see. So here's where we actually associate the subnets with the route tables, and this is where we determine what's public and what's private. So the public route table that we set up with the route going to the internet gateway, we associate that with the subnet that we call public, and same deal with the private stuff, but for a route table that is not going to the internet gateway. Our network ACLs, again, we got one that I want to associate it with the public subnet, a different NACL set for the private subnet. And then down here, we're establishing some of those rules. So I think I just did this for the public. So we got one for allowing traffic inbound on a NACL, gave it a rule number of 100. I think a -1 for the protocols means all. The action is allowed. Here's the IP address. And I think we've got corresponding stuff for the outbound traffic. And here we're going to associate the NACLs with the subnets. And here we're setting up our security groups. And again, this is not the subnet level. This is at the EC2 level. And so it's just different protocols and ports and the IP addresses. And again, we're only able to allow, we can't explicitly deny, and this is stateful, so we don't have to specify inbound, outbound. We just have to say this traffic is allowed on this port using this protocol. How would you have egress? And you can see I'm tagging everything with a name. There's a security group for any EC2 that would be in the private subnet. We'd want to associate that with this security group. And then finally on this, we have outputs. And so again, we're going to give each output its own identifier. Description is not necessary. The value is referencing some of the stuff that we've already created. So this will reference get the VPC ID that we've established here. I'm not sure what the exclamation points are. Okay, damn it. All right, yeah, and it doesn't seem like it blows anything up, but you'll see, like earlier, we have references without the exclamation point, and then I've seen some with it, and I'm not sure what the difference is.
Well, ref is the key. Like, the ref there is the value of, the key is the word value, so it's confusing. But so I think ref is like an actual YAML feature.
Okay, man.
Yeah, I think it's like saying reference this other thing, but the reference is like in the value itself. That line is very confusing because the key says the word value. But if you go down to line 216, the key is name.
I got you. Okay.
Anyway.
Okay. Yeah, I had no clue. So, but yeah, so we're using the sub functionality. So now, initially I had this stuff hard coded, but now we're just going to say whatever this stack name is, which we'll create at runtime, dash VPC ID is going to be this export value that we're going to pass out. And same deal with some of the stuff with the subnet and the security group. And so we'll spin this, we'll run this template, and this will create all this stuff here. Oh man, you'll be good, man. You're doing it earlier, all right. Pressure's on.
going in Mumbai?
No, it should be here.
US West.
That'd be nice.
Nice.
Yeah. Kidding me.
Fire.
Oh, this is old tabs. All right, don't ask questions. All right, so yeah, we're in Cali. Good old Cali. And so yeah, this is the CloudFormation GUI. So you can use the template designer. I've never really done that, but we're just going to select use a file that's already available to us. That is this one we're working with. So we're going to go next. Here's where we're going to give it a stack name. So we'll just call it full stack. If you wanted to, establish some more tags, you can do that right here. Here's a place for these IAM roles we can associate. There's nothing to really associate that. We didn't set anything up. I think here, if you want to set up like SNS, which is a simple notification service, you can do some stuff with this to where when your infrastructure is being spun up, you can have email alerts going out to you and kind of let you know what's happening with that. But we're not going to change that. So there's a little review section. It's kind of showing you the template URL, stack name, rollback on failure, which is nice.
I didn't know that was an option.
I didn't either. Not sure
I
why.
thought that was the default. I thought that one just, if any component fails, I thought it rolled everything back.
And it,
I didn't know you had a choice to do that.
yeah, I mean, I'm not even sure where you would set that, but it was doing it a bunch this weekend when I was trying to work this stuff out. So.
Well, that's a cost saving thing for you too.
Yeah, no, you're right. Oh, you gotta be kidding me. What's going on here? Killing me. This is rough.
When developers started implementing the estimate cost feature on Azure, was like, no, don't finish that.
I assume you can run that using the CLI as well.
And I would imagine SDK. I haven't done either though. I've seen CLI options. I haven't seen anything for the SDK as of yet.
I tried to use the CLI with S3 and it's a challenge.
Is it?
At least for me it was.
Is that like Bodo 3 or
What's that?
is that like Bodo 3? Is that
Oh, no, three.
Bodo?
The Python, yeah. I think you
They literally got a CLI you can download. AWS.
but there's some, it has something to do with Bodo 3 though. If you want to download that on your laptop or whatever, I think you need Bodo 3 or.
Well, I think it started out as like a totally separate third-party thing or whatever. But I don't know. I looked at a couple Python things and they were showing how they were using Bodo 3, which they could script that. And I think it's just a library on top of their CLI
Yeah.
because that thing's like 7,000 options or something.
That's the CMD.
So, well, this
I mean,
thing.
I remember like back in the day, there wasn't even they didn't even provide a web interface like for S3. Like you had, so I think a lot of their stuff was someone came up with it on their own and then they copied it and brought it in.
So usually when internet connectivity is fine, you'll see a list of events, what's happening with your stack if it's spinning up.
So the stack you're creating now, so how many researchers are in there? What's all?
Whatever we just walked through,
Oh, okay.
that was that, yeah. So we have two stacks, so we'll get this one going, hopefully, and then the other stack will actually install an EC2 into the stack we just created. And that was the whole point.
Oh, there you
Where we go. So this stack here, everything should be free. So this will be available. So if you wanted to just spin this up, it's just the VPC components, subnets, the NACLs, all that stuff should be free. The EC2, which will just be a micro, that'll cost a little bit. So if you want to spin that up as well, just keep that in mind. The cost isn't a lot; it's like 2 cents a minute or an hour. But yeah, so you got create complete. To your point, yeah, at any point, had anything failed, it would have rolled back all of this, which is nice. And so yeah, so now we can go out here and we should, I guess I probably should have shown this first, but had 49 availability zones, getting bigger.
Yeah.
Where we going? Let's see. All right. So you see we have 2 VPCs, and we got one that's named VPC1, and I guess should have pointed that out. Yeah. That was the key value name that we gave it. Just hard coded that in there. That's our new VPC. We can go look at some subnets. See a private subnet, again associated with VPC1. And again, this is just a big reason why you should always use key value tags for your stuff, just because of this, if nothing else. There's some other cool stuff you can do, like I'm on the DevOps team and we're tagging all of our stuff DevOps something something, and we created a Lambda function that will go out and look for any components that are DevOps dash, and at 7 p.m. we'll shut everything down, all EC2 instances down. 7 a.m. we'll spin them back up. So that's a cool thing you can do with tags. But it's just helpful on the human eyes too, just being able to identify the right components that you're looking for. So yeah, we got a private subnet, our public subnet. We can look at some route tables out here. We got these tagged as well. Again, you see they're associated with this. You always get a default route table regardless. Amazon's not going to let you shoot yourself in the foot. But since we explicitly created some others. We got those as well. Internet gateway, there should be 2 of them out here, one of which is associated with our VPC. So that's that. So then the other template that we have is this one. This is a lot smaller. So this is just going to launch an EC2 into our existing VPC. We're going to actually pass in some parameters here, the operating system that we want and the name of the parent stack. And so operating system, you see we can have a default. We're giving it a type. This is different than the AWS type, but it could be Boolean, it could be integer, string, there's a set of your usual data structures, which is using string, allow values, and we've got our parent stack. And again, there's no real allow values, but it's a string type. Here's that mapping section I was talking about. So remember the AMAs, they're regionally scoped. So North Virginia, an Ubuntu AMI is going to be this, Red Hat AMI is this, in California, Ubuntu is this, Red Hat is this. And again, I'm not sure why Amazon just doesn't make it all the same across the board. They don't. But in theory, now we should be able to take this template and run it either in Virginia, California, or in Ireland. And it's just me just randomly picking places and getting their respective AMIs. And if we plop in Ubuntu or Red Hat, we should get the right AMI. And I'll show you where that's happening. Down in our resources section, this is where we're going to spin up our type of EC2 instance. For the properties, our image ID, this is where you can hard code that AMI ID, but then it's going to be kind of tied to a specific region. Here we're going to use this find and map. So region map is the name, I'm assuming, of this region, of this map. We're using that reference to say, okay, the AWS region, so that's kind of baked in, so CloudFormation will know I'm in the Northern California region. And so then, and that's tied to these little labels. And there's a website where they can map, for whatever reason they want, I don't know why they just didn't call this North California, but US-West 1 is the Northern California region. This translates that for you. And then reference my operating system, that is this Ubuntu value or Red Hat value that we passed in. That's the ID for that. And assuming we passed in Ubuntu or Red Hat successfully, and assuming we're in one of these 3 regions, we should pull out the correct AMI as opposed to hard coding that in there. And then again, the instance type is T2 Micro, very small, very cheap. I already created a key, Cali1, and then here's our block device mapping, just one drive with that. delete on termination is 2. We got a volume size of 10 because Red Hat, I guess 10 is the minimum. Network interface, this is going to give us internet connectivity. This is the last piece that will allow the EC2 to be available via the internet. And then we've got tags, name value stuff. Here we're going to use sub, and we're going to put the operating system, so either Ubuntu or Red Hat after this portion. And then we got user data, which will do some small bootstrapping, essentially just trying to install Apache. And this isn't working properly. I wanted to be able to say, hey, if my operating system equals Red Hat, then run these 2 Red Hat commands to install Apache. If it's Ubuntu, run this. And for whatever reason, the Red Hat stuff just is not working. So we'll launch an Ubuntu, and hopefully that will show up with Red Hat or with Apache on it. And then we'll try Red Hat one to see if that works, but I'm not confident. So we're going to go to Create Stack. And we're going to select this template here. Wait for 7 minutes. All right, so stack name, EC2, call this Ubuntu. And you see here we got those parameters, so we can choose either Ubuntu or Red Hat. Shit, was it full stack? Was that the name of the old stack?
So it got the interface got the parameters out of the file you actually just loaded.
Yep. From that template we just walked through. Got that. Again, you got your tags. You can apply at runtime if you want to add some additional tags. IAM role, the advanced stuff. Got that. Create. Oh shoot. Let me show you something real quick on this other stack. So the outputs, I forgot to mention, these are the 3 outputs that came out of the original stack that we just set up. We want to ingest some of these outputs for like the security group and the subnet. That's what we're going to use to set up our EC2 instance.
Can you go back to the part where it was showing the regions on the file?
Sure.
So that mapping that's there based on the region you're in when you're running it. Is that true?
Yes, absolutely. Yeah. Yeah, so CloudFormation, all this stuff is happening within a specific region. So yeah, had we run this in like Mumbai, it would blow up because it was, I don't know. Yeah. And I'm sorry, I guess I should have probably made this more of a, draw more attention to this. So yeah, so these import values, when you set up an EC2, when you want to set up the network interface, you want to associate that with, publicly accessible subnet and a security group as well that, is going to allow you to have HTTP access and whatnot. And so we set those up in the other VPC and the other template. And so now we're referencing these values by using this import value function. And that's why I needed to remember what was the name of the right stack. And so as long as there's a full stack dash FSG dash public ID thing out there, identifier, which there should be, and the outputs, yeah.
What are outputs again?
The value. So if you create an EC2, you have to associate it with the security group. And so if you're within the same template, you could just reference, the security group that you create in that template. But these are 2 separate templates. And so we create the security group in the first template, and we want to output the actual security group ID, which I think is this right here. That needs to be associated with our EC2. And the way the EC2 is able to map back to that value is by going through this name that was exported. We're actually going to import looking for that name, and that's going to map back to the security group value. And again, if you're doing this all within the same template, you don't have to worry about that. You can just use the ref function. But because we're in 2 different templates, we have to use that export functionality from the first template, which is at the bottom here.
So a way to share the info between those 2.
Yeah, it's a cross-stack reference.
Yeah.
So, yeah, down here, this is where we're exporting that value. And I could have hard coded the name. I just wanted to dynamically, whatever we change the stack name to, I just wanted it to be able to pick that up. But yeah, this value is related to this key is related to this actual value. And that's the core thing that we need to pull out and associate that security group value with our EC2 instance.
So when you're doing like your NAT addressing where you're taking public interface and translating forward to obviously it's not networking, but it's still
Yeah, there's a translation happening there. Yeah, it's just, yes. Yeah, for whatever reason, yeah, you just can't reference the security group ID, which is what you ultimately want. You can't reference that directly from a different template. You have to go through the exported value and then get to it like that. Hope that's somewhat clear. So hopefully, got to create complete. Yeah, still Cali, so let's get out of here and go look for our EC2s. There should be one sitting out here. There we go. We got an Ubuntu EC2 that's up and running. We got a public IP address, which I'll try to access this right now, but this is my work PC, so they've got all kinds of firewalls and stuff like that.
Crap.
If somebody wants to plug that into their phone, you should see a Red Hat or a Apache page. Sorry. $52, $53, $197, $180. Nah, I didn't. What? All right, I lied.
Is the 480 next?
Oh, let's check it out. Yeah. So we'll go to our security group. There we go. So we're looking for,
Oh, it says refused.
yeah, it's there. Of course, didn't work. Yeah, so that was actually working by itself. We can try doing that. Let's see. Let's see, go back.
Oh my gosh.
So that's right there. What's up? Oh, I think you said something.
So you got it, do you?
Let's see. So, what am I doing here?
Thank you, service, Apache 2 status.
No.
You have to.
Oh, yeah. Not sure why that didn't work. It's working all weekend. All right, well, I'll get that cleaned up. I'm not really sure why that failed. Sorry about that.
Putting your request stage into your server. From there on, you're just totally in the normal Linux, whatever world. There's no like Amazon specific
No.
stuff in the.
This is the bare metal.
Just base install Ubuntu, right?
Yeah, and so it didn't work. Okay, yeah. Let me figure out what's going on with that. Red Hat was giving me issues all weekend. I'm not sure why Ubuntu crapped out.
Are those stripped down? Like bare OSs or whatever?
I don't think they're
Because
just
on the internet,
yeah. That just because we just did that though. Yeah,
is it, do they?
it was supposed to work from the CloudFormation template. It's supposed to install. And,
Right.
Yeah.
They load it
Yeah.
up. Working out.
I apologize for that. All right, so the tunneling though. So we did that.
It's up.
It's working.
Yeah, it's working now, but that's because we just did that there. It was supposed to work from CloudFormation. This was supposed to install it right here,
Oh,
right? And obviously did not. So
huh.
Does not start.
Well, that's HTTP, right? Oh, no.
that was for Red Hat.
Yeah.
Yeah.
These are, runtime more essentially.
I'm sorry. Oh, this here?
Yeah.
No, that's fine.
Yeah, but that's an install, but it's not a start.
But yeah, this weekend I was just it wasn't even installed though. Yeah, and this was fine because I initially had the 2 commands and I didn't necessarily need that. I'll figure it out.
Is it your on 57 your else?
Yeah, I mean we could swap out and see if that does something. Maybe.
On that get is minus y flag. I know that is on young, but I don't know about that get.
The minus y.
Yeah.
Yeah, I thought. Yeah.
You might actually have to provide it earlier in
So does Amazon constantly update those AMIs or whatever for vulnerabilities?
No, that's on you. They've got a shared security model, so they take care of like the infrastructure and the hardware, and it's kind of up to you to handle all the software stuff. Unless you use like a pass, one of their managed offerings, and they'll handle that stuff for you.
I think they keep their Linux AMIs. Like, you have to, like, kill your machine.
Oh, maybe something like that.
You have to, like, launch a fresh machine, and you can attach your volume to it.
and that's why it has to come out. Yeah.
Sure.
Well, that's what the documentation says.
Well, that's another question. Is there any like logs that you can see with the CloudFormation, or you saw the little hardware ship partial complete?
Yeah. So I'm not sure about as far as anything other than this is the only thing I've actually ever really looked at. So let's see. And I mean, you get this, and I'm sure there's other stuff you can get. I'm not familiar. Brian, were you going to say something?
Is the EC2 instance now connected to the
EBS? Or,
EBS? Yeah.
yeah. Those,
So, but is there still configuration you have to do to connect to that, or is it just?
it's, I mean, it's a mount, right? It's just a drive. You don't have the EBS volume? Or-
Yeah.
Yeah.
So
So
it's, they exist, and you could use it if you had software that's taking advantage of
yeah,
it.
we could put like a database on this right now, and it would use that drive. And let's see. Yeah, this block device mapping is where that happens here. So let's go into the.
You guys do 12-factor apps?
I'm not even sure what the 12 factors are.
But you've heard of it.
Oh, here we go. Sorry. Yeah, there's our little guy. Let's see. 10 gigs. I thought there was something where we could see what it was associated with. Oh. Yeah, so it takes you. So yeah, it was just that block device mapping portion. That's all you need to at least get the initial connection set up.
So the block storage is by itself, but the EC2 is on shared hosting.
It requires an EBS volume to launch. So you pay for the time that, some of them come with the EBS volume like automatically attached. I thought like that.
They all do.
Onto an SSD specifically, you don't actually have to go.
Oh, I
Yeah,
got you.
I guess they do all come with like a EBS one attached and then you pay extra.
So once upon a time, you used to be able to just get EC2s with no EBS volumes.
Oh no! If you
Oh.
launch the micro and then you stop it, that volume is like attached to that micro. And then if you destroy the micro, that volume goes with it. But then if you have an EBS volume separate that you attach as the OS, then you destroy. I think when you destroy the VM, like if you had you have your like a Linux install, then you can launch another instance and just attach that drive back into it. But you have to do that like that's separate. If you just launch VPC with the EBS, when you destroy that image, that volume goes with it.
It depends on how you set it up. Yeah, that flag on there for delete. Termination. And change it.
So I guess it's right. It's like I don't know if that's answering your question or if you got it.
I think I'm starting to understand that. Like, so one of the things, total kind of new question here that I don't get about shared hosting is like, because I kind of dealt with this easily using Heroku, which is like platform as a service on top of it.
Right.
Service, which you can like have shared databases, you know, and everything. Or your databases server is shared, so you can like /d to list all the tables and stuff, and all of a sudden you get like a list of thousands.
Oh,
of, like,
really?
other
Wow.
tables. Yeah.
That doesn't happen here.
Yeah. But so when you get the EC2 instance, you're getting your own processor, but you're on like a shared. It's not a shared server, is it?
It is.
Sure,
They
sure.
do that. They do like that. They isolate.
Yeah.
On a VM, they're basically like VMs that get launched. So it could be on metal with a bunch of.
Would you? I mean, but you'd never be sharing processing power with anybody else.
Well, yeah.
Yeah.
Yeah. You're on the same box, right?
Yeah.
So
you have like, is it when you get 8 gigabytes? Is it like 8 gigabytes maximum, or like 8 gigabytes possibly? Then like
It's allocated to you.
it's allocated
well,
to
no,
you?
the storage wise, yeah, you get the 8 gigs. I mean,
I
that's
mean,
Everything is allocated to you based on what you pay.
but like throughput or whatever, that can
so
vary.
There's like some gatekeeper between,
Yeah, it's all virtualized. I think they use
Or-
KVM.
or you just get like a certain number of cores or something.
Yeah.
Yeah, those. You know, when he said don't keep going down the list because they're going to give you more cores and more
Yeah.
and all that, you have to pay for all that because they're setting it aside.
Right.
There's like 3 different levels, right? There's on demand, reserved, on
So
demand.
you're gonna get
Slot,
like 2 or 4 cores on a processor that could have like 120 more.
Right.
There is some there's a bunch of stuff online that we're talking about the micro, the smaller instances where you definitely don't.
Oh, they're trash.
Proven that like if it has 2 cores and it's supposed to have that amount of memory, it definitely does not scale like as your workload. The box like starts petering out,
Yeah.
because they're free.
Yeah,
So
pretty
no,
much.
unlike a workload that you really care about.
Not a real production site.
Right.
There's a
For
bunch of
playing around. It's the first bit of crack.
yeah. That
Yeah,
was,
that's yeah, absolutely.
that was just like that was one downside that people were saying that they would rather go to DigitalOcean or Google Compute Engine if you were going to use
The smaller one, okay.
Because if you go to Digital Compute, they did a bunch of testing and be like, oh, if you get this hardware, this IaaS host, you actually get what you paid for versus
Yeah.
Amazon stuff.
I've even heard with the CPUs, you pretty much have these, 2 equals 1, 4 equals 2.
Obviously, Meetup.
Right, yeah.
Chances are they're just using like a vSphere or something like that. Cloud. I'm not sure they're not using vSphere, but I'm saying they're just standing up VMs. So however they're doing the virtual hardware emulation, they're giving you 2, but that doesn't mean you're actually getting that much
Right, right,
hardware.
right. Yeah, 2 nickels, little
I have
dime.
a general question for I have a friend who is another company and he hosts a bunch of websites for clients. He was running on EC2 for a while, which I thought was And I asked him about it recently. He's like, oh yeah, we switched over to DigitalOcean or Linode or something. And he's like, it was just the cost. Like the cost of EC2 was so high. And so I'm not, because like usually you hear that the costs are actually low unless you need to scale it up really high. And I guess what I'm wondering is like why, like if low cost isn't the factor, like what are the benefits you're getting from EC2 versus just using like a DigitalOcean or a Linode? Or is it other
DigitalOcean, Linode, you get them per month, 24 hours a day, 7 days.
Yeah, the way their billing's different. So DigitalOcean, I don't know if Linode works the same way. DigitalOcean has a cap. So like if you get a server that's $20 a month, it's charged, even if it's off, you still have to pay.
Right.
But like when you factor out the cost, it's like, oh, $1 a day.
Right.
And that would be $30. But once you hit $20, you just pay, that's the max you pay for the monthly with their billing. So
Yeah, I run a Linode and I get a certain amount of resources on my VM. It's literally a VM.
Yeah.
And it's on all the time for that amount of money.
Right.
I pay $5 a month and it runs that server for 24 hours a day, 7 days a week.
So maybe it's like if you were running an EC2 instance 24 hours a day, 7 days a week, it's gonna wind up costing more. But
you would do
Yeah.
you only
It's
need
by, yeah.
But where EC2s come into play is when you want to get away from, when you want to start clustering or you want to start doing horizontal scaling dynamically. So you start combining their services together. Then you start getting, well, if the load on these two servers gets to 80%, spin up another one and add it to the load balancer and do all this, and it manages your entire network for you. And then the elasticity of that is what they have. You can't do that necessarily with Linode.
Even if you don't need a server, if you want to just test some software,
Right.
you could spin it up and pay 50 cents.
Right, exactly.
And turn it off.
Yep.
And if you're a data science person and you need to spend that 250
Yeah.
for one day or whatever,
Yeah, sure.
you're running function 7 when it's distributed out over 250 servers or something.
Yeah, that makes sense.
But EC2s to me don't make sense for a single server.
Right, I think that was probably the wrong use case.
Well, you can still maybe, if you're worried about price, you can still maybe get away with it like reserve pricing. You can maybe, it's an upfront commitment, but you can bring the price down like that. Or if you want to roll the dice, you can try spot.
For pricing, you're not standing up one VM or one EC2.
You could with reserve, yeah.
Yeah, you can.
It's just the upfront commitment. So you can say, hey, I'm going to have this EC2 for like a year, and I'm going to commit to paying that. You'll get you'll get a discount on that. And then you can pay for it up front, like 100%, and you'll get a really steep discount. Or you can say, no, just bill me every month, but I'm going to commit for the full year,
And then like with reserve, if you really care, if you turn off any of your reserve instances, you can set them up on the spot market and you can make
Oh, is it? Oh, a little arbitrage, man. Nice.
That's how spot works. Is like as people you have reserve, it's your peak maybe or like your mid level, and then like for Netflix, it's new. So
Right.
these instances are off, they stick them up on the spot market.
No
and they
shit.
push money off, and then come 7 o'clock.
Oh, yeah, they got 'em back, yeah.
And they get it back. They steal. That's like part of their reserve thing is they can steal the spot from underneath whoever.
Oh, yeah, no, absolutely. Damn, wow. Okay. Has anybody actually messed with spot pricing?
It's cheap. I didn't know you put your capacity back on per spot.
I think that was the
I didn't know that either.
reserve.
I'm a sucker.
That's how you end up making your money back.
I should have been doing that this whole time.
I doubt if you can. I don't know. Do you think you can? It's a 1-to-1, or you just get some of your money back, so you don't?
I don't remember. I had money that went from Netflix.
I'm sure Amazon steps in there.
Because spot price is pretty freaking low.
I don't even know what like the pricing would be.
Like data science, you need to. If you're going to do data science,
It's
you
like
want
a-
to run a whole day
it's like a,
just on spot and wait.
It's like a
Okay.
PayPal or like eBay. It's like a fluctuating market depending on
Yeah.
who's put their reserve stuff on.
Was it like run by Amazon or something?
Yeah, it's Amazon.
But the thing is that you spin up spot instances, but since I think because they're reserved, someone can steal their instance back from you, so you're not guaranteed that they'll like last. And I think their spin up time is slow because you can say, "Oh, I want 1,000 instances on the spot market,"
Right, just fulfill the demand, yeah.
So you pay for reserve if you want, or you pay for price if you want.
No, it seems like it's a commodity market. That's
I
what
think
it
it
is.
used to be a bigger issue when you paid for your junk. So like Amazon, I think used to be by the hour. You'd spin it up NEC, and you'd have to pay by the hour. So if you spun it up for 5 minutes, you pay for an hour.
Yeah.
So then spot became a big deal because I don't need it for 5 minutes, so I'm gonna go grab it off the spot for 5 minutes. You claim somebody else's EC2.
Yep.
But now I think they're down to the second, right?
Oh, it might be a minute now at this
But
point.
it's still,
Yeah, a lot better
it's
than an hour.
significantly smaller than it used to.
Yeah. So,
It's not just reserved, it's reserved or on demand. Either one of those will preempt response.
Yeah, I mean,
It basically has to be, nobody else will pay more, so instead of letting it sit there. we'll let you-
yeah, so as long as your application can withstand that, then yes, Spot is great. But so we're talking a bunch of prices. So this is actually the next slide. So you guys have already kind of chimed in. So obviously people are familiar with the pricing. Per hour is what I still have up there. But yeah, you're right. They may have just come down to like per minute pricing. Demand reserve spot, we just covered that. EBS has different types of pricing. You got provision IOPS. If you want to guarantee a certain throughput, you can pay for that. S3's got its own types of pricing. And that's kind of, and then VPC is free for the most part, except for like Elastic IPs. It's a little wonky. CloudFormation is free to use, just you pay for the online resources. RDS has its own type of pricing, which is going to be a little more simple, but a little higher than like, bare metal stuff. But the key takeaway is pricing is weird, like with the cloud stuff. And the reason why I mentioned it here is because of the next slide, the downside slide, which it sounds like we're already kind of getting into with respect to AWS, terminology, processes, pricing. There's a learning curve when you're messing with the cloud. Performance and price, especially if you're running your stuff on premise, like if you're heavily utilizing it, you're probably not going to get a price discount by going to the cloud unless you start doing some weird stuff with spot pricing and reserve and stuff like that.
It says that EC2s are priced by the second,
Oh.
minimum 60.
Oh, 60 and 61.
So you're going to pay 60 seconds regardless.
Wow, damn. Yeah, right, exactly. That's the only reason.
You can get it by hour or by second.
But no, it sounds like you could 60 seconds minimum, but it could be the 62nd second. That's all you pay for, 63rd second. That's wow. Shit, okay. Are you seeing any kind of actual pricing charts for that, or
Hold on.
okay? So I wonder.
There's so many variables.
Yeah. But yeah, so, price performance, it's the flexibility. So yeah, Matt already kind of answered that. That's what big AWS draws. And then just too much power for Amazon. You worry about too many users stressing out the hardware. At some point, there will be some kind of breaking point. We're not there yet. Amazon retail, man, they've muscled out some of the third-party sellers on their website. If you're selling BB guns and they're going gangbusters, Amazon has been known to jump in there, negotiate with your suppliers, and pretty much, yeah, like there was an expose on that. Not all the time, obviously, but if they're doing that on the retail side, what's to say that, this is like your data. This is your proprietary code that you're putting up in the cloud.
They'd be able to automate, like, figuring out your data. That surely the expose must have been sellers on the Amazon.
Oh no, it was totally, yeah, right, yeah. But it just, that's a totally different, muscling out a BB gun provider is different than stealing somebody's data, but it just shows the culture, Bezos doesn't care that much, So you just got to worry about that. So it's nice to have, hopefully, a multi-cloud strategy to where you can look to Azure or Google or even IBM as, alternatives. That's a big reason why Amazon's really pushing all these great services, these PaaS offerings. They want you really beholden, to their ecosystem. And it's like, and it's great. A lot of their stuff is really cool. Like Amazon Aurora is a really nice database, but it'd be nice to have the flexibility to go to a different cloud provider if Amazon says that's what you want
That's
to do.
the part that I'm most cautious about with the Amazon stuff is the vendor lock-in.
Yep.
It's funny because so much of this technology was, decades of open source stuff, and that's what they built their infrastructure on. And then it's like, oh, you can say that about any company for sure.
Yeah. Android, anyone?
There's a term in sales called land and expand.
Yeah. I don't know, I think it's a funny short anecdote about the critical mass of users stressing that AWS infrastructure. You mentioned it before, but last year, AWS went down for like a few hours, which I think took Netflix down too. And then, so my company, we use Media Temple. And Media Temple had an outage, total coincidence, like a week later. And so our servers were down for a couple hours, and our clients were like, oh, my website's down. And we're like, it's just the server. But we were like so grateful that Amazon had gone down the week before, because we'd be like, it just happens. Like Netflix went down last week, and they're like, oh yeah, that's right. I was trying to watch a movie and it went down. So it was like, man, if that hadn't happened, I would have been like, what kind of amateur operation are you running?
Amazon's about the only thing that can bring Netflix down.
Yeah.
Because they have that chaos monkey or whatever.
That chaos gorilla.
Arbitrarily just killing shit.
That's cool. That's some cool shit.
And I think that's the one big one when they went down. Like my buddy worked on chaos, and that was like the one where Amazon was having issues where the East Coast went down, and then they try to fail over to the next region, and then that region, it takes that region down.
Wow.
I think they started like
Chaos.
when they were at Netflix, they were talking to Amazon about fixing that issue.
Oh, okay.
Part of that was like the one East Coast outage. If they had not rolled over, the rest of the regions would have stayed up. But then it just rolled failure across the U.S. because the region, the next region couldn't handle all the failure traffic. So I think most
Systems thinking, man. I had not heard that.
I can't even imagine working for AWS, working on this infrastructure stuff. It's like, it must be so insane.
Oh, yeah. Absolutely.
I've had 3 friends that have worked for Amazon as architects or security engineers and stuff, and they're all wicked smart. So I wouldn't put it. I mean, all those guys are total integrity guys, but I don't know everybody at Amazon, right?
Sure.
So you never know. I'm saying that if they wanted to, I'm pretty sure they could figure out what you were doing as far as secret sauce.
It's a risk. It's on the slide. Because Amazon also has like the HSM, the hardware security module, whatever, where they're like, hey, this is your own dedicated piece. This is black box. Even our engineers cannot get to this thing. And so I work in healthcare IT. So we were looking at this stuff, for HIPAA compliance. And so it's like, okay, well, if you have that option where you're saying this is a black box to us, that means all this other stuff is not a true black box and you can't get in there, right? So,
Another one, at my old work, like the main lead architect at AWS came, they talked about, they have like some proof where they have a data center, and nobody in the data center has rights to any of their boxes, and all they do is just plug stuff in, and then there's like a small subset of people, like if you can physically touch the hardware, you don't have that, right? It's like
Well, separation.
yeah, like real low separation, and then it's all automatically like configured. They just scan everything, like autopilot, it's all there.
and this is AWS? Or?
Yeah, they said you would just get racks of equipment, and they tag the equipment, and then it auto configures like the whole rack. So it's like so much stuff.
Nuts.
The government has classified boxes that you can't open them. If you open them, it
Fries,
crashes
everything.
it or whatever. So that's how they do it. Is they set it up. Tech can set it up, and then it gets remotely configured. And if anybody touches anything with it, it erases everything on there. The government has Gov Cloud,
Oh, so,
Yeah.
yeah.
That just goes into this stuff.
and they have this whole FedRAMP security thing that they have to go through. So they basically formed up the Gov Cloud to be able to meet all the controls and everything.
Yeah, we were looking at that stuff and we were trying to determine if we were HIPAA eligible. So yeah, don't want to leave it on like a negative, like those are the downsides. Possible next steps, deeper dive into security, some of the CloudWatch monitoring elasticity that Matt kind of alluded to. That'd be kind of cool to, explore. DNS, elastic load balancing, elastic IP addresses, and deal a little bit more with the private subnets and the NAT gateways. So if you guys have any interest, want to present on this stuff or just, work on it or whatever, I'm definitely going to continue exploring it. So, But yeah, no, this is really empowering stuff, and I mean, this has only been around for like not even 15 years, and just the fact that we're all talking about, you know, some of the downsides and risks with Amazon Web Services, but the fact that we could, in theory, right now, spin up a pretty sophisticated data center within like a half hour. That's nuts. That's insane, and it wouldn't cost us, but you know, dimes or nickels out of the pocket. That's pretty significant. So these are some of the resources I used kind of preparing for this. You know, yeah, there was one CloudFormation book that I saw available, which was actually pretty helpful. You know, not entirely helpful because it didn't work, but yeah, that's my fault. I think. But yeah, that was pretty cool. If you're interested in studying for the SysOps Administrator guide or exam, I used the official book that came out late last year for SysOps. I used the A Cloud Guru videos, which was like 9 or 10 hours of videos, and then Wiz Labs has practice exams and practice quizzes. So those are the three things that I used.
Is those free?
Wiz Lab or
Look like the A Cloud?
no.
They're very cheap if you catch them on a deal.
Let's say you, I don't know. You did for a bundle, yeah. Udemy, you get like $10 or $11 per. Yeah.
I've done A Cloud and done Udemy. I like A Cloud.
Yeah. So you know. So yeah. I'm gonna make this available too if you wanna.
Is WizLab on there?
No, it's not on there. I can put that link out there
Let's
too.
just practice this.
That's yeah. But that's the thing. So you know, I went through this entire goddamn book, and I went through the Wiz Labs exams and the sample exams. It was those that really helped me pass. Like the stuff in the book is all in there, but it's just so much. And so the exam is only like 55 questions. Yeah, you know.
AWS documentation is overwhelming.
And yeah, right. I mean,
you spend 6 months reading 8 hours a day, you can read it all.
right. And you probably wouldn't pass the damn exam even if you did that. You know, it's like
unbelievable
yeah,
material. Just
a lot out there, man. And what's crazy is roll this up in 10 years, this is going to look quaint, the amount of data that's out there right now. So, but anyways, yeah, that's what I got. So, thank you guys for coming out, and thank you for.
What were your